So for logarithms, for a positive m, a positive n, and a positive a also is not equal to 1. Log base a of m equaling log base a of n, so same base. That means that what is inside your logarithm, those have to be equal to each other. So if we had 3x equals 20, one thing I can do here is I can just do a log of both sides. So what we can do is that because this is a base 3, I can do a base 3 log of 3 to the x is equal to a base 3 log of 20. So I'm actually combining sort of like two rules here. So we know that this is still equal to 3x equals 20, but I'm going to use that log base 3 to undo this 3 on this side. Okay, so like I said, we're just ensuring that the equality stays here. So because I know that this tells me that this can happen, that also means that this happening means I can do this as well. So I'm just reversing my last property. Now log base 3 of 3 to the x is just x. So we have x is equal to log base 3 of 20. And that would be an exact answer. If we need to go further, we need to approximate. Well, that means we would just have to find natural log of 20 divided by natural log of 3. So just using the change of base. Natural log of 20 divided by, not natural log, common log of 20 divided by common log of 3 will end up being 2.72683. We'll round it to about there. So that would be the approximate answer. So this would be the exact solution because this is going to be an irrational number. So no matter what I do, I have to round it if I try to make it into a number. So for number 14, same thing. We want to solve the following using logarithms. So we got e to the power of 0.08t equals 2,500. So once again, we're just using those properties to, as you saw last time, we can use the properties of your logarithms to break these to some sort of log. It just have to be the same base log. And ideally, we're trying to undo a base. Same thing here. We got 4, x plus 3 equals 3 to the negative x. All right, so for A, because we have E here, I'm going to do a natural log of both sides. Now, when I do that natural log, all it's going to be left with is, because that's a base E log, that's E, I'm just left with the power of 0.08t on this side, and I'm still left with natural log of 2,500 on the other side. So to continue over here, if I just want t, I divide both sides by 0.08, so t would just be natural log of 2,500 divided by 0.08. And if you want an approximation of this, natural log of 2,500 divided by 0.08, this is roughly 97.08006. Let's change this 5.8. Let's round it out a little further. We've been rounding to 5s lately. Or 5th place. So for B, we can either do a log base 4 or a log base 3. Either one's going to work. I'm going to do log base 4. Log base 4 of 4 x plus 3 is equal to log base 4 of 3 minus x. So over here on this side, because it's a base 4, I'm just left with the x plus 3. Here, as a reminder, because I have an exponent, I can pull that exponent out front. So log to the 4th of 3 to the negative x is really just negative x log base 4 of 3. So if I want to solve this, I need to put all my x's together on one side. So I'm going to add to both sides x plus, or the plus x log base 4 of 3x. This is going to leave me with x plus x log base 4 of 3 would be equal to, oops, sorry, I forgot we got this plus 3 here. Plus 3 is equal to 0. So if I subtract 3 from both sides, I'm going to have x plus x log base 4 of 3 is going to equal negative 3. Now both of these have an x term, or sorry, an x in them, so I can pull it out and do factoring. So this would be just leave me with 1 plus log base 4 of 3 equals negative 3. Just to make a little extra room to finish this out. So what we have here, if I divide both sides by 1 plus log base 4 of 3, x is just going to be negative 3 over 1 plus log base 4 of 3. Let me try to quickly approximate this. If you want an approximation, negative 3 divided by 1 plus, so I'd actually have to do a common log of the 3 divided by the common log of 4. So we can change that, but that's going to give me a negative 1.6, we'll say 674 because I'm running out of room on here. So just to go back over this, these would be the preferred answers. These ones here, those are our oops, sorry, trying to fix something here. The other ones are our approximations. So depending on what we're doing, like sometimes we like the approximations, but really for the most part, you want to try to keep things exact answers. So we would just leave like natural log of 2,500 divided by 0.08, or we'd leave as negative 3 divided by 1 plus log base 4 of 3.